finished, right?
Oh, yes, sir. We were supposed. Yes, sir. I finished. Sir, one more thing. On Monday, you said I just gave you a few class numbers and their date so that you could just add them in the Google Classroom, but you didn't.
Which one? I don't understand what.
Like, sir, like 12th October's class. 12th October, 7th October, and 30th
Oh, I see.
September.
The recordings.
Yes,
Recordings. Okay, recordings. About recordings, what is my suggestion? That is, these recordings are available with you, right?
Yes,
Isn't
sir.
it?
But actually, sir, যখনই ক্লাসের কথা মনে পড়ে তখন জাস্ট স্ট্রাইক করি গুগল ক্লাসরুমের দিকে যদি ক্লাস রেকর্ডিং লাগে।
Yes, yes.
So তখন আমার মাথায় জাস্ট এগুলি আসে না, স্যার।
Okay, so for only this few recordings, you have to take little bit time. Okay, you should give me some time because I'm till this week I will be very busy. Okay, and when I'll
Okay,
become
sir.
free,
Then
I will upload. And if it is necessary, emergency for you, then you check it from your one.
No problem, sir. I will remind you next week's second class.
Yes, yes. No problem. Inshallah, I'll do. I uploaded some, right? The one you sent me, I uploaded some. Did I?
No, sir. Actually, I just gave 3 classes number and you didn't did any of them.
Okay, maybe for other classes I did, not your class. Okay, fine. You will tell me the answers, eh?
Yes, sir. A.
Are you done with all the MCQs?
Yes, sir. All the MCQs.
And structured?
Actually, not all the MCQs as well because I think I might have not done yet. Means middle if problem for that.
Did you try all?
Yes, sir. I tried all.
Yeah, that one I need. What about structure? Did you try it all?
No, sir.
Okay, tell me the answers, please, quickly.
Yes, sir. A for America.
Yes. Say the number and answer. Number, answer this way.
Okay, sir. LTA. Yes, sir.
One is done. It's okay. Then two.
1 America.
Yeah. Then 2.
Okay, sir. 2 Bangladesh.
Okay, go on.
3 China.
Yes.
4 Bangladesh.
Cross. 4 cross.
4 cross.
Go to 5. Go to 5.
4 cross. 5 America.
Yes.
6 America.
Cross. 6 cross.
Okay, 7 Dhaka.
Yes.
8 Dhaka.
Yes.
9 question mark.
9 question mark. Okay. 10.
Yes, sir. 10 Dhaka. 11 China. 13 Dhaka.
12.
Sorry, sir. 12 Dhaka.
Hmm.
13 Bangladesh.
Cross.
13 Bangladesh.
Cross.
Okay, sir. 14 Dhaka.
Hmm. Yes, go.
15 Bangladesh.
Mm-hmm.
16 America.
Cross.
Sir, 16.
Yes, cross.
Okay, sir. 17 China.
Yes.
18 Bangladesh. Sir,
18.
18.
18
18. 1 8
cross.
18 Bangladesh.
Cross.
Hmm,
Yeah, how many you got cross?
I need to count, sir.
Yeah, check how many.
1, 2, 3, 4. Sir, 7. Sorry, sir. Sorry, sir. 6.
6. Then one is question mark, right?
Yes, sir. Including question mark.
Okay, including. Then which one is first? 4, right?
4. Yes, sir.
Okay. So can you read
China.
this? Yeah, can you read this question?
The diagram shows a wire XY lying between the poles of a magnet connected to a sensitive ammeter. The wire is moved and a reading is in which direction is the wire?
Okay, so what is the condition to get induced EMF? To get
Fleming's right hand or left hand rule.
uh, left
Fleming's
hand
left
rule
hand.
or right hand rule? Fleming's which rule? Listen, the notes I am giving you are not going through. That's making you to answer this way. I clearly mentioned that if there is current already given, from there you will get Fleming's left hand rule. From current you are getting kinetic energy. That is Fleming's left hand rule. And it must be written in your notes. So it is Fleming's right hand rule, right? And it is related to induced EMF. It is related to AC generator. So why we are getting this induced EMF? Hmm? Can you check? Uh, Karim, can you
Yes, sir.
check your notes? At the beginning of this topic, I gave you induced EMF. What is written there? Karim,
Yes, sir.
your
I
writing.
was not able to write that part. Means you're supposed to give me the recording and I need to write. Here I have wrote induced EMF, then slash, then nothing.
You did not draw the diagram.
Yeah, I did.
So from the motion, what happens? from the motion of the where we
Induced
are
EMF.
cutting the magnetic field lines, right?
Yes, sir.
And because of this, we are getting induced EMF. So write it now. You got this worksheet printed.
Yes, sir.
So you write that due to movement of the wire, we are having magnetic field lines cut, and that's why we get induced EMF. Yeah, Karim, did you write?
Yes, sir.
Okay, now look, uh, if you are moving the wire towards C or D, then magnetic field lines are not cut. What is the direction of magnetic field lines from north to south, right?
Yes, sir.
So if you are moving from forward to backward, then magnetic field lines are not cut because magnetic field lines are in that direction. So it will just go parallelly over there. And if you are taking B, it's not also cutting the magnetic field lines. It is also going, in a way that it's only staying in one place. It's not cutting the magnetic field lines. But if you are going through A, moving up, then magnetic field lines will cut. Or down. You can move up or down to get magnetic field lines cut. Is it clear to you?
Yes, sir.
So you write this note also. We should go. We should have the motion of the wire either up or down, either upwards or downwards. Then magnetic field lines will be cut.
Yes, sir. 10-6.
So what is your answer here?
Sir, America.
Then which one? 6.
Yes, sir.
Okay, so it's a tricky question. If you don't think deep, then you cannot understand it. Which option you chose here?
Sir, America.
America. You chose P and R. So
No,
why
sir.
you
P and Q.
P and Q? P and Q you chose. They are asking you where is the bottom of the magnet when there is no induced electromagnetic force in the coil. So again, the same idea. If there is any movement of the magnet, that time we had movement of the wire, right? Isn't it?
Yes, sir.
Now we are having movement of the magnet. And in your notes, if you check, you have Faraday's law of induction. Is it there? Hello? Is it there?
Yes,
In
sir.
your notebook, Faraday's law of
Yes, sir.
induction. What is written there?
The EMF, electromotive force generated in a conductor, is proportional to the rate of change of magnetic flux, which we also can say magnetic field lines density, linking the circuit. So we can get induced EMF by the motion of conductor or by the motion of magnet.
So here we are having motion of the magnet. Now, if you want to have this answer, there is no induced EMF. That means there is no motion, right?
Yes, sir.
So which part you are getting where is no motion? Underline it. No induced EMF, and it will be happen if there is no motion. When there will be no motion?
When it will stay at a constant place.
Sorry?
When it will stay still at a constant spot.
Yeah, correct. But from your diagram, you have to say me that spot. From PQR, you should tell me where is
Sir,
that spot.
sir,
Yes.
it is like either it is in P or Q or R. If it just stays there, then it will not create any EMF.
Which one?
Sir,
Which position?
it it can stay in any position, just it needs to stay
No,
still.
no, no. Not any position. You see,
If
when
if we don't want to make
listen,
EMF
listen,
now, then
listen,
it should be
listen,
at Q.
listen. In our lab also, physics lab also, we did some experiment with spring oscillation. Can you remember? So when you are
Yes, sir.
pulling the spring, like if you are pulling the spring and to make the vibration, to make the movement in the spring with the magnet, you have to pull it, right? First, you have to pull it
Yes, sir.
till here, and when it is pulled till here, at that moment, it is stationary, right?
Yes, sir.
And then you released it, it started moving back, right? So
Yes,
when
sir.
it was in this position, it was stationary, isn't it?
Yes, sir.
And now when it's going up at one stage, it will return back, right?
Yes, sir.
And just before returning, it is stationary for a while. Just before returning, it is stationary for a while, isn't it?
Yes, sir.
Without uh, without being stationary, it cannot return back, isn't it? So it can be
Yes,
for
sir.
fraction of seconds, but it will stay stationary for a while, then it will return back, isn't it? So that position is which one? That is
P.
P. So in P it is in rest for a while, and in R again it is rest. Because when it will come here, then again before returning up or going up, again it's stationary for a while here in R, isn't it?
Yes, sir.
So now it's clear, right?
Yes, sir.
Completely clear, or you have still any doubt?
No, sir. Completely, sir.
So it is a nice question, right? tricky
Yes, sir.
questions where you learn something. Then next.
9, sir.
So the way I labeled everything, did you label that way?
Yes, sir.
Everything you should label. Okay, all the information as much as possible you take. Otherwise, after some days you'll forget again. Then which one?
9.
So about relay, you don't have any idea?
It is a small switch which allows us to pass means it is like a circuit. If we pass electricity through it, we can on or off much bigger circuit.
So which one could be the possible answer here? Hmm? Which one could be?
I Sir, I'm really confused.
Why confused? Where you are confused? You already just told me the answer. What you told me,
I
just repeat again. You write here. What you told me, you write here. Then I will understand why you are confused. Are you writing?
Yes, sir.
Karim, how long it will take to write?
Sir, I am typing. Uh, can you see it
No, no, I can't see it. Nothing is here.
now? Because I'm done.
Not yet. I I still can't see your writing. Now it's came. Yeah, it is a small circuit which is used to switch a bigger circuit. So which one is matching with this one? A small circuit means what? It's containing a small current, a small voltage, right?
Yes, sir.
So bigger circuit means what? It's containing a small current,
Bigger
bigger
voltage.
voltage. So which one is matching with this one? Just you relate to this idea you have, you'll get the answer.
China.
So you know it.
Chinese.
You know it. Why you are so confused?
Sir, what is read relay? Can you
Huh?
explain? What is
Read
read relay?
read relay. It is also available in your notes. In topic 17, we taught it you in class. Read relay.
Actually, sir, I can't find it. I tried to find my copy,
Yeah.
but
How can you find? You are writing
Yes.
today in one paper, tomorrow in another paper, and yesterday in
No,
another.
sir. In school, sir.
School, everywhere you are like that. Everywhere you are like that. Okay, and
Sir, can you
that's why,
just tell me the structure of read relay?
yeah, I'm showing you. Just wait. I'm finding it from your book.
Sir, I also find there, means try to find there, but it wasn't.
Yeah, it is not possible for you. It will take 5 years for you because you are busy with lots of things, right? Go to page number 347 in your book.
Just let me get my book. Yes, sir.
So you got there, read switch,
What was the page number, sir?
347. Got it?
The simple. Oh, yes, sir.
So read it, read it. Last paragraph you read. When a magnetic field from a permanent magnet, from there.
Or an electromagnet is brought near the reed switch, the reed become temporarily magnetized and attract each other, thus closing the contact. This enables the external circuit to which the reed switch is connected to be activated.
So clear now? Is it clear now?
Sir, that means we are using the right hand rule. Wait, the right hand rule.
Here no right hand left hand rule. Here only we are having magnetic field, external magnetic field, and here we have,
Sir, how, sir? Means uh, it is saying that terminal A and terminal B. So if we need to, uh, okay, sir, got it.
you draw this diagram now. Beside your question, draw this diagram. Then you can remember.
Done, sir.
Then next, which one?
13.
Hmm? 13.
Yes, sir.
You did not get these notes?
Yes, sir.
Didn't you get this note? In topic 22, you did not get this note? Hello.
Yes, sir.
So from there you can find it. Two conductors, they are attracting each other. So why they are attracting? When they will attract each other? Your diagram is there, writing is there, everything is there.
Uh,
So why you are not seeing it from there in notes?
Sir, I try to do it practically, means with the grip rule.
Don't do waste your time now. Go quickly. You cannot understand with only one. You should have two, both. You don't have two right hand. That's why I need the diagram.
Yes, sir. Sir, 16.
Hmm. 13, what is your answer?
Sir, America.
Okay. 16. Yeah, what is your answer? 16.
Sir, it is America.
Why America? If you can remember, today only you wrote 3 points, right? 3 points, three factors which can increase induced EMF. Did you write on your copy? Hello? Hello, Karim? Hello, Karim?
I don't know.
Okay, so in your notes, is it written the three factors how we can get more induced EMF? Is it written?
Let me check, sir.
Karim,
Sir,
yes.
I can't find it.
So you are not writing the notes properly. That is your problem.
No, sir. Whatever you say, I write it, but the
Really? So,
classes I missed two notes, not whole, just a part
okay, now
for
you
which,
write. Now you write. Now you write.
sir, in which
Induced,
part?
here you write on your worksheet. Induced EMF can be more if the speed of the coil or Magnet is more.
Sir, speed of the coil
Coil or wire.
means the speed of the rotation of the coil.
Yes. Just speed of the coil, you're right. Rotation of the coil. Of course, it will rotate or move. Something will happen, right? Speed of the coil is more than magnet is stronger. Number two, if the magnet is stronger, then third, number of turns are more.
Sir, magnet is
Stronger. If the magnet is stronger, then we'll have more magnetic field lines density, isn't it?
yes, sir.
And they will be cut more, and you will get more induced EMF. Then the final one is if there is more number of turns in the coil. So now you check that they are saying when the speed of rotation of the coil is doubled, then you will get more induced EMF, isn't it?
yes, sir. Means the number of coil is increased.
Rotation of the coil is doubled. Rotation, that
Okay,
means
sir.
speed,
Rotation of the coil.
speed, speed, speed is doubled. So if it is doubled, the speed is doubled, then what happens?
It becomes A.
Speed is double, then your in one sense part of A will come, like frequency is more, right? If
Yes, sir.
speed is more, then frequency is more. This is fine, but you also have more induced EMF, isn't it?
Then it will be D.
Yes, because your y-axis is showing you the EMF, isn't it? You
Sir,
got, you
that
got,
means
you got
they
AC.
are
Listen, you
inversely,
got,
they are proportional. Yes, sir.
you got AC generator graph, right? In AC
Yes, sir. I
generator
have
graph,
AC generator.
yeah. In your
Yes,
AC
sir. I have
generator
it.
graph, you got the EMF in y-axis, isn't it?
Yes, sir.
So if your EMF is more, then your amplitude will be more, isn't it?
Yes, sir. Could you repeat?
If your induced EMF is more, then your amplitude will be bigger, isn't it?
Yes, sir.
That's why the answer should be D. Your frequency is more and your EMF is also more. Is it clear now?
Sir, that means they are proportional to each other. If
Proportional to
all
each
other
other
factors are
means,
kept constant.
yeah, proportional means if you are increasing speed of rotation of coil, then frequency is more, it's clear to you, right?
Yes, sir.
Frequency means number of complete cycles every second. So if your rotation is more, then your frequency is more, there is no doubt. And if your induced EMF is more, then amplitude will be more.
Yes, sir.
That's it. Simple. Nothing
Okay, sir.
here more complicated. So you write here 2 points. Number one, here induced EMF is more, and number two, the frequency is more. Induced EMF is more and frequency is more. Then next. Which one is next?
Sir, induced EMF is more and
Frequency is more.
D is right.
Dhaka. Next.
Yes, sir, it would be 18.
18. You did not answer.
I answered wrong, I guess.
Okay, so the idea just now you got, I think if you apply this idea, you can get the correct answer. Could you please try? Have a try, huh? Kareem?
Sir, I tried.
Now you try
Sir,
because
this took me the most time.
no, I'm saying now you try. You got the idea now from question 16. That idea you use, you'll get it.
Sir, if the speed is
It is
constant,
it is the same
then
idea of
the
16.
yes, sir.
It is giving
Yes,
you
sir.
the same idea of 16.
Yes, sir. I'm just speaking out what I am thinking. Then you would be able to correct me.
Yeah.
Okay, sir. So the graph shows the output of a AC generator. The coil generates 20 times in 1 second. Okay, this is a normal information. The speed of the rotation of the coil steadily increased, means it is increasing gradually.
Yes.
That means the frequency will increase.
Gradually, not
Yes, sir. Means gradually increase.
yes. Then only frequency will increase.
The amount of EMF will also increase.
Yes. So which one is now your answer?
It would be D then.
So you got it. We are successful now, right? You understood.
So that means we just get a simple idea that if we increase anything, all of them are proportional to the number of EMF produced.
Yes, you can say that, but think it's simple, right? Not proportion, directly proportional, inversely
Sir,
proportional.
actually, I can
You
remember those things easily. So I
okay,
just try
fine,
to get them out that way.
fine, no problem, no problem. So you got it today, right? So that's our
Yes,
achievement
sir.
today. So have a break, huh? For 6 minutes, you are having a break, okay?
So let us take it to 10 minutes round.
Yeah. 10 past 9 will start, okay?